Dear students, in our previous class, we have discussed regarding stacks, regarding queues, and we have completed the queues topic. But in today's class, we are going to discuss a new topic that is called as linked list. Linked list. And this linked list is one of the classifications of a data structures. As we have discussed, the stacks and queues and arrays, the same thing like that. This linked list also the classification of data structure. So here, dear students, why we will use linked list instead of using arrays? Because arrays is a static representation. In arrays, if we want to insert a new item or new element into the array, then the data elements or the data items which are present in array will be shifted to the higher memory locations. This is one of the problems. And next, if we want to delete any element from the array, at the time the higher data elements will be shifted to lower locations. This causes a huge problem because the array is a static data structure. So here, insertion and deletion of elements creates a problem. To avoid this problem, okay, instead of using arrays, linked lists are used. Come, we shall see what actually the linked list means. Okay, come, we shall see linked list. Linked list is an ordered collection of data elements called nodes. Okay, it is a linked list is an ordered collection of data elements called nodes. And the linear order is given by means of pointers. Linear order is given by means of pointers. Linked list is an ordered collection of data elements called as nodes. I will explain you what is meant by node later. Then, and the linear order is given by means of pointers. Okay. Now we have to understand first what actually node and what is a pointer. Okay. In arrays, okay, if you take stack or queue, take a stack. In that, if you insert anything, okay, this can be called as element or item. Element or item. The same way here in linked list, an item or the data element can be called as a node. And this node contains two parts. Okay, the first part represents the data and the second part represents the reference. The first part contains the data, okay, and the second part contains the reference. Here, each node is having two parts, okay, it contains some data, okay, then the reference part will be connected to the next node. Reference part will be connected to the next node because the data part contains the data of the node. Okay, it contains its own data, and the reference part contains the link, or this can be called as the pointer, and this can be called as pointer. We will start every linked list by the pointer. This pointer name is called as start. Okay, pointer name is called as start. See, this is a pointer start. It is connected to the first node. Okay, the node has two parts. The first part is the data part, and the next part is the reference part. First part contains the data of its own. Okay, it contains data of its node. And the reference part contains the pointer to the next node. Okay, if next node, it is also contains some data, and this is the reference node. This is connected to the, again connected to the next node. Okay, so this is called as linked list. Here in arrays we will use items or elements, but here in place of items or elements in linked list, nodes are used, which contain two parts. The first part is the data part, and the next part is the reference part. The data part contains its own data node. Okay, and the reference part is a pointer to the next node. So node means this element, and pointer means which is connected to the next node. This is called as a linked list. Okay, linked list is an ordered collection of data elements and nodes. Okay, and the linear order is given by means of pointers. Order is given by means of connecting pointers. Okay, see, this is a node, and every node has two parts. One is data part, and the other one is reference part. Data part contains its own data. Okay, the node, first node contains its own data in its data part, and the next part, that is reference part, it points towards the next node, and it is connected to the next node. So this is called as a linked. By giving one more example, I will explain you the linked list. I will try to explain you the linked list clearly. See, this is a node. It contains two parts. First part is the data part, and the next part is the reference part. Okay, it contains its own data, and reference part will be connected to the next node. Okay, then it always starts from the pointer called as start. This can be called as a pointer, and this is connected to the first node. Okay, then the next node contains its own data in the first part, then this will be again connected to the next node. Okay, then finally the last node will be null. Null. Okay, here in linked list. Okay, what is the advantage of using linked list? Here in linked list, if you want to insert any element, okay, then any node, then that can be inserted very easily. Node 1, node 2, node 3, and so on. Okay, so this type of data structure, we can call it as the linked list. Now, as we have types of stacks and types of queues, the same way here, types of linked list are there. There are three types of linked list. Types of linked list. There are three types of linked list. First one is single linked list, or we can call it as singly linked list. Singly linked list. The next one is circular linked list. Circular linked list. And the last one is doubly linked list. Doubly linked list. So these are basically the three types of linked list. One is single linked list, next one is circular linked list, the other one is doubly linked list. Now we shall going to discuss these things one by one. What actually mean by singly linked list? What is circular linked list and what is doubly linked list? First, we shall discuss the singly linked list. A singly linked list contains two fields in each node. Two fields in each node. Okay, as I have explained, okay, singly linked list contains two fields in each node. This is a node which contains two fields. Okay, then the first one is the data field. The data field and the link field. The data field and the link field. See, first one is the data field. Okay, the next one is the link field. Listen here. One more thing. You can call this link field as reference field, and reference field can be called as a link field. Both things are same here. Singly linked list contains two fields in each node. Okay, the data field and the link field. First is the data, one is the link field, and then the data field contains the data field contains the data of the node. The data field contains the data of the node. Okay, it contains its own data, any data. Okay, here nothing is restricted. Okay, any data it may contain, but the data should be its own data. Okay, here the data field contains the data of the node. Okay, this is node, and in its data field it is containing its own data. Next, the link field what the link field will contain. Okay, why the link field contains the address of the next node. The address of the next node. This link field contains the address of the next node. This type of linked list can be called as a singly linked list. So here, since there is only one linked field, only one link field in each node, so it is called as singly linked list. The linked list is called as singly linked list. Singly linked list. Okay, here it is clearly explained. A singly linked list contains two fields in each node. This is a node containing two fields, and this can be same as the definition of the linked list, but little bit extended. Okay, listen here. Here, singly linked list means it is clearly explained. But in linked list, only the definition of linked list has been given. But here it is clearly explained what actually the singly linked list means. Singly linked list has a node has two fields. The first one is the data field, the other one is the link field. The data field contains, okay, its own data, and the link field contains the address of the next node. Okay, I will show you, I will draw the linked list, then I will show you, you can understand clearly. Okay, link field contains the address of the next node. Okay, then since each node contains only one link field, okay, later you will come to know when the two link fields will come. Okay, since each node contain only one link field, so this type of linked list will be called as a singly linked list. Okay, hope you have understood. Now I will write a linked list here so that you can understand it clearly. See, start. Okay, it is a pointer, and look, the start can also be called as head. Don't get confused. Start and head both are same. Okay, then this is start pointer. Okay, here I'll write nodes. Node 1, okay, then 2, then 3. Okay, 3 nodes I have drawn here. See, pointer start. It contains to the, it connects to the first node. This is node 1. Okay, it contains some data. Data field contains some data. Okay, and this is the link field in every node. And what this link field contains? Okay, according to this explanation, link field contains the address of the next node. Okay, but in node 2, in the next node, okay, there is no condition that only 2 or 3 nodes, it may be n number of nodes. Okay, then it contains its own data field contains, then link field is connected, or it contains the address of the next node, and this will be node 3. Okay, then it contains its own data, and finally it has null pointer because no node is there. Okay, so it contains null. So this type of linked list, which is having only single link field in the data in the node, so this type of linked list we can call it as a singly linked list. Okay, next come we shall discuss what is meant by the circular linked list. Circular linked list. What is circular linked list? In circular linked list, if the link field of the node, the link field of the node contains the address of the the address of the first node, the address of the first node, such that such a linked list is called as such a linked list is called as circular linked list. Circular linked list. Little bit extended definition is there. I'll write below here. Okay. In a circular linked list, circular linked list, it is possible to reach. It is possible to reach any node from any other node, from any other node. So we shall see what is meant by circular linked list. Circular linked list. So here listen. Before explaining this, I am going to explain you one thing. In singly linked list, one drawback is there. What is that drawback? The drawback is this one. In a singly linked list, okay, only every node contains only the address of the succeeding node. That means address of the next node, but it will not follow the preceding node. Okay, when two nodes are there in singly linked list, okay, then the first node contains the address of the only succeeding node, next node, but it will not contain the address of the next node. Okay, this is the drawback of singly linked list. So to overcome by this drawback, okay, we will use circular linked list. The circular linked list is that what it is explaining. In a circular linked list, if the link field of the node contains the address of the first node, link field of the node, sorry, it may be in a linked list if the last field of the node, this is like this, last field, not link field. In a circular linked list, if the last field, if the link field of the last node, I think, yes, link field of the last node, link field of the last node, okay, in a circular linked list, if the link field of the last node contains the address of the first node. Look here, this is a pointer. This can also be called as head, okay, head pointer. Connected to data field, okay, then this is connected to next node, okay, then this is connected to next node. What it is saying here, the link field of the last node, contains the address of the first node. Link field of the last node contains the address of the first node, okay. So this type of linked list is called as a circular linked list, as I have shown you in circular queue. Okay, the same type here, it is circular linked list. Okay, the link field, it is a link field. This is data field. Link field of the last node, okay, contains the address of the first node. So this type of linked list is called as circular linked list. Here, one more advantage is that here in a circular linked list, it is possible to reach any node from any other node. If you want to reach from this node to any other node, you can reach easily. Or from this node to a first node, you can reach easily. So this type of linked list will be called as a circular linked list. And the last one, that is doubly linked list. So we shall discuss now what actually the doubly linked list means. Doubly linked list. Okay, it is a linked list. It is a linked list in which each node points to its next node and the previous node So this type of linked list is called as a doubly linked list. Okay, in doubly linked list, each node contains three parts. Okay. In every linked list we have seen, in single linked list, each node contains only two parts. And in circular linked list, each node contains two parts. But in doubly linked list, each node contains three parts. Come, we shall see which are these three parts. The three parts are, the first one can be called as forward. And in short, this can be written as for. Then next can be called as back. Forward, back, and the last one is called as info. Three fields. So if it contains three fields here, okay, then imagine what kind of node it should be. Okay, look here. Now I am showing you the doubly linked list node. It contains three parts. Okay, and this can be called as back. Okay, and this part can be called as forward, and this part can be called as info. Okay, it contains its own information or data. Okay, then it explains each node. It is a linked list. Which one? Doubly linked list. It is a linked list in which each node points to the next node. Okay, it points to the next node. Okay, and the previous node, and also the previous node. So this type of linked list can be called as a doubly linked list. Okay, in doubly linked list, each node contains three parts. One is forward, next one is back, next one is info. Come, we shall see what is forward, what is back, and what is info. What is the use of these three fields in this doubly linked list? First one is back. Okay, it contains it is a pointer field. It is a pointer field containing the address of next node. Containing the address of next node. Sorry, containing the address of previous node, because it is back. It is back. Okay. This back field contains the address of the previous node. Okay. Next we shall see what is meant by forward. Forward is also a pointer field. I will write here forward. Okay. It's a pointer field. It is a pointer field contains the address of next node. Contains the address of next node. It is a pointer field that contains the address of next node. Forward is a pointer field which contains the address of next node. Next info field. Info. Okay, this field, it contains the actual data. It contains the actual data. See, this is the info field, okay, and it contains its own data. So doubly linked list is having a node which is having 3 fields, okay, and doubly linked list can be explained as it is a linked list, okay, in which each node is connected to its next node and to its previous node. And doubly linked list is containing 3 fields. The first one is back field, next one is info field, next one is forward field. You can write as you like, forward back info or back info forward, like that. Then what actually the use of back? This back field contains the address of the previous node. It is a pointer field, okay, or the link field or the reference field which contains the address of the previous node. Then forward, it is also a pointer field or the link field or the address field that contains the address of the next node. Then info field, it contains the actual data, its own data, the info field of a node will contain. So this is regarding the linked list. In short, I will show you the difference between the singly linked list, doubly linked list, and the circular linked list. There you will understand it completely. Okay. Singly linked list, circular linked list, or we may take like this: singly linked list, then circular linked list, then doubly linked list. Look here, students. Here, singly linked list. What it explains? It contains 2 fields. Okay, each node contains 2 fields. Okay, one is the data field, another one is the link field. Okay, the data field of the node contains its own data. Okay, and the link field contains the address of the next node, and singly linked list contains only one link field. So for this reason, this can be called as singly linked list. But in doubly linked list, okay, in circular linked list, okay, here in circular linked list, look here, okay, circular linked list, the link field of the last node contains the address of the first node. So this type of linked list will be called as circular linked list. Here advantage is that we can reach any node from any node. Okay, this. Then doubly linked list. Doubly linked list contain doubly linked list is the one in which each node or link field of each node, or it can be explained as it is a linked list in which each node connected to its next node and to its previous node. And this type of linked list is, in this type of linked list, each node is having three fields. The first field will be called as back field, the next will be called as forward field, and one more will be called as info field. This back field, this is a pointer field containing the address of previous node. Forward field, it's a pointer field or the link field or the reference field containing the address of the next node. This is also a pointer field or the link field or the reference field. Then info field contain its actual data, its own data. So this is totally called as linked list. So these are the types of linked list. Okay, hope you have understood regarding linked list and types of linked lists. Okay, in our next class we shall discuss the operations on linked list, just like traversing, insertion, deletion, and many more regarding linked list. Okay, then insertion contains insertion at beginning, insertion at middle, and insertion at last. Then deletion contains deletion from beginning, deletion from middle, or deletion from last. Okay, all these things we will discuss regarding linked list in our next class. If you have any doubt regarding today's class, you can ask me personally. Thank you.